So the classified paper 2 and the topic 2.2, the thermal properties and the temperature. So aluminium block has a mass of 200 gram and the specific heat capacity of the aluminium is 900 joules per kilogram. So specific heat is in joule per kilogram and the mass is in gram. So we have to convert into kg, because if the specific heat was joule per gram degree centigrade, then we'll use a mass in gram, but it's joules per kilogram. So the mass must be in kg. So to convert the gram into kilogram, we divide by 1000. So that will become 0.2 kg. How much energy is needed to increase the temperature from 20 to 110? So we have the formula that energy E is equals to Cm delta T, where C is a specific heat, M is a mass, and delta T is the temperature change. So specific heat is 900, that's given. The mass is not 200, the mass is 0.2. And the temperature change, it starts from 120 and end at 110. So means it increases by 90, or you can also write 110 minus 20. Temperature change is always the greater value minus the smaller value. So when you simplify this, you will get 60,200 joules as a energy needed to change the temperature of this 200 gram or 0.2 kg block of aluminium. Is it clear?
Yes.
Okay. The question 2 is the same question related to the block of aluminium. Then we have question 3. When a bridge is built, a gap is left in each concrete slab. So maybe you have seen these expansion gaps are there. When they build the bridge, they keep some gap between the sections of the bridge. A small gap, not a very large or a big gap. So why are these gaps left? So what will happen? The options we have, the concrete expand, because when something heated, it expands. So concrete might expand on a warm day. So that's true. Concrete contract on a warm day, that's wrong, because it will not contract, it will expand on a warm day, because when substance is heated, it expand. If it cool down, it contract. The gas expand on the warm day, that is true. This statement is not wrong, but we are talking about the concrete slab. So this question is not related to the gas will expand. The gas which is here will expand, but this is not related to the question. Even though the statement is correct that the gas expands on a warm day and the gas contract on a cold day. So these two statements are correct, but they're not related to the question, that because the question is why there is a gap between the concrete block or a concrete slab. So the main reason is that when it gets hot, the concrete slab expanded. Is it clear, this question about the expansion gaps?
Yes, yes.
Okay. Next we have question 4. The specific heat capacity of P is greater than Q. We have the formula that specific heat capacity is energy divided by mass into temperature change. That's the formula for specific heat capacity. So if the specific heat capacity is greater, it means the energy needed will be more, or the mass will be smaller, or the temperature change will be less. So what does this statement mean? Like if we say that specific heat capacity of the P is higher than Q, so which statement explains this idea? Less energy is needed to raise the temperature by 1 degree for unit mass, means like 1 kilogram P, then Q. That's wrong, because P is having the higher specific heat capacity. So we need more energy for P and we need less energy for Q. But in the first statement, it is written opposite. That's why A is wrong. Less energy is needed to melt. So if energy needed to melt is not about specific heat, that's about the latent heat. If it was about the latent heat, then even the latent heat means energy needed to change the state. So if P was having a higher value of the lattice energy, like the latent heat, it means P required more energy as compared to Q. Then more energy is needed to raise the temperature for solid P as compared to Q, that this statement is correct. Like we need greater amount of energy to increase the temperature, like we need the same greater amount of energy to increase the temperature by 1 degree of 1 kilogram P as compared to that of Q. That's why the water is used as a coolant in a car radiator, because the water is having a higher specific heat capacity. So it can absorb greater amount of energy and it shows a very small change in temperature. So why not other liquids are used? Why the water-based liquids are used as a coolant? So the main reason is because the water is having a higher specific heat capacity. So it needs too much energy or greater amount of energy to increase the temperature by 1 degree. So it will not boil off quickly. It will take time to boil. In question 5, a student placed a number of the ice cubes in a container with a hole. He left them to melt. So the water dripped into the beaker placed in the balance. The student record the initial mass and the final mass. So this is about the latent heat. The latent heat is removed from the current syllabus. So we'll skip discussion as it's not part anymore. Only the specific heat formulas you have to learn, not the latent heat.